Hi sir, I am Govindan, 31 years old. I am from Vellore district. I did my academic studies at the year of 2012. After that, I have joined additional course in NX CAD CAM and AutoCAD course. That was a 4-month course. After that, from that date until now, overall I have 12 years of experience. In these 12 years of experience, I have learned a lot of information, lot of knowledge and lot of experience in the domain of semiconductor industry nearby 7 years and automobile industry nearby 4 years, remaining mold and die industry, medical and aerospace component handling. In semiconductor industry, I have worked for this customer ASML Holding, ESEC Holding, Philips, Adata Semiconductor, Alpha Semiconductor. I have good knowledge in front-end, back-end process of IC chip manufacturing in the semiconductor industry. Front-end process is nothing but from the beginning up to middle of the process. Back-end process is nothing but from the middle to up to end of the process. That was called the back-end process. Now we are going to see about front-end process. In front-end process, the wafer manufacturing is first process. Oxidation is the second process, photolithography is the third process, etching is the fourth process, doping is the fifth process, deposition is the sixth process, and final process is repeatability. From the photography process until deposition process, it will be repeatability several times until get thin layer. The first process of wafer preparation is nothing but it is a silicon preparation. The silicon is nothing but it comes from sand on ingot into the multiple slices of silicon wafer. The minimum diameter of the wafer 100 mm diameter, the maximum diameter of the wafer 300 mm diameter. The next process is lapping and polishing. After finish the polishing, they are going to check surface roughness testing. The result value is it comes under the nano. If the value is below than the single nanomicron, this is a high surface finishing quality. Now the wafer stage is non-conductible, so we need to convert to the semiconductive parts. For this purpose, we are going to make a oxidation process. Oxidation process is a deposition of layer by using dry spray or vapor spray. While doing this process, the wafer is rotating, then only it evenly gets spread complete equal thickness of the layer. This is made by a centrifugal force. The next process is photolithography. In this process, we are going to add one more layer. The layer name is photoresist. After installing this photoresist layer, we take one glass mask. This mask made by glass, which is designed by a computer. Whatever our required the circuit of design. Above the mask, we are using the UV photo light. We are going to pass this through mask way. Then based on this mask, the unwanted materials are removed from the photoresist. So this is called photolithography. So now in this stage we cannot able to remove oxidation layer. So for this purpose we are going to add the etching process. In this etching process, wet etching and dry etching is we are going to doing. By the help of etching process, unwanted area selectively we are going to remove from the oxidation layer. Now we are doing doping. Doping is nothing but a high energy ion. We are going to implantation into the selected area. The ion name is N type and P type. There are two type. N type is nothing but it is a boron. It is located in the atom table number 5. Boron have 3 atoms and boron have 5 number of positive protons. The P type is nothing but phosphorus. Phosphorus is have 5 number of electrons and 15 number of positive proton have. And P and N ions controlled by a PN junction. After that, the next process is deposition. In this process, we are conducting based on the requirement PVD and CVD. PVD is the physical vapor deposition, CVD is the chemical vapor deposition. After that, this process from the photolithography until deposition, it will several times repeatedly need to do because of it until get thin layer. Now the front end process is completed. Next we are going to enter in the back end process. In back end process, first is the testing. Everything there are perfectly working or not. Then once tested, after going to the next process is the dicing. Dicing is nothing but slicing of a wafer. After slicing on single wafer, it comes to 2000 number of pieces of wafer. After slicing, we are going to the next process is die attaching. In this die attaching, with the help of support arm, the pick and place arm, the die is nothing but the sliced wafer is called as die. With the help of pick and place arm, it moved to the respective place from the one end to another end. Now we are going to see in briefly pick and place system. In this pick and place system, we are using the rubber product and silicon product and Vespel and metal part and suction cup for using pick and place system. In the rubber product is called as NBR rubber and metal part is used for Vespel, SK11, like that. The NBR part is made by a two method of process. One is direct molded rubber, another one is non-direct molded rubber. First we are going to see non-molded rubber. In this process, the raw rubber is molded a standard size. Once complete this standard size of raw rubber, it is going to convert a manual operation by the help of engraving machine, laser machining, laser marking, and surface grinding machine. In this surface grinding wheel is dressing by the form of product shape. In this operation, we are conducting minimum hole diameter 0.3 up to customer requirement. Here using the engraving machine, the RPM spindle speed is 60,000 RPM. After finish the machining process and making process, this is going to the next process, deburring process. In this process, we are using The deburring tool is diameter 1 mm carbide tool. It have a three angle face with sharp edges. And next is this one is here the cleaning liquid is using alcohol only. Once completed everything and visual inspection and dimension inspection they are conducting. Once completed everything, then ready to pack. Now we are come to the direct molded rubber part. In this area, based on the customer input dimension, we are going to design a mold base of design core and cavity. Based on core and cavity, it comes a molded rubber. Here, while molding, in the molding machine parameter, we are using for NBR rubber, melting temperature is 180 degree and curing temperature is 150 seconds. In silicon only, using the melting temperature is same 180 and curing temperature only curing second is different, it's around 400 seconds. Once complete the molded part, after directly go to the visual inspection and dimension inspection and curing. If required curing and not required cannot go curing. After cured the part, then the X-ray test is there. In the X-ray machine, we are going in X-ray machine we are checking chlorine value and silicon like that. In chlorine value, mandatory it required 700 parts per million. If go above the 700 parts per million or less than above the 700 parts per million, it is easily contact with the metal part. Then it will go to corrosive stage. So that's why we controlled 700 parts per million chlorine level. In this X-ray machine, we are using Rigaku machine. I am proud to say I am the license holder of the Rigaku machine for the testing purpose. The next testing is hardness testing. Here hardness testing is for silicon need to come 60 to 70 HRC. For NBR rubber it need to come above 85 HRC. Then the next is PSR resistance test. Here the most important stage, because of here the resistance level need to control 10 power of 4 up to 10 power of 9. This is called as semiconductor resistance level. Rather than otherwise is one is conductive or non-conductive. So within this region we are acceptable for the semiconductor material like that, otherwise we are rejected. So the next level is packing. And next process, the holder manufacturing. The pickup holder. In pickup holder is stainless steel and non-KT material. In this pickup tool surface finish we are checking in surfcom machine. This surfcom machine have stylus is diamond stylus. It can check up to 2 micron level. And for the adhesive purpose, dispensing nozzle and spanker tip. In spanker tip we are maintaining the tolerance level 5 micron tolerance level. The next process is wire bonding. Here we are using for wire bonding purposes gold wire and copper wire and aluminum wire. Gold wire is for the medical and aerospace component and copper wire is for the other domain. The diameter of the gold wire is 0.1 starting stage up to 0.45 and copper also 0.4, aluminum is a 0.2 diameter. The wire gold coating thickness is 7 micron up to 14 micron level. And the next process is encapsulation. Here encapsulation is nothing but a sealing of the IC chip. Here for encapsulation we are using ceramic and epoxy mold compound. The next process is laser marking process, which is the customer brand name need to engrave, and final inspection process. After completed everything, final inspection, then we need to packaging for this to the original equipment manufacturers, that means our customer. So these all are the back end process and forend process of the IC chip manufacturing. My overall experience, I have worked in product development department and detail drawing department and NPI research and development department with the help of UGNX software and NX CAD/CAM and AutoCAD, and I have involved in manufacturing side also. I have strong knowledge in manufacturing, milling process, turning and surface grinding, laser marking, X-ray machine. In testing side, surface surfcom test, hardness test, roughness test, like that. So these all are my about overall experience. My present company is Salcom Technology India Private Limited. Here also I am working ESD controlled environment only. In my career I have worked ESD controlled environment around 7 years. So fully I handled ISO 9001 company and ISO 14000 company, which means it is suitable for the semiconductor industry. So I can able to convey myself for the semiconductor industry. I know the world number one cleanest industry is the semiconductor manufacturing industry. For that we need to prepare ourselves also. So these all are my about myself. Thank you for giving this opportunity.